Couldn't ask for a better introduction than being called the head nerd farmer. Okay, so I lead a group at the MIT Media Lab. If you don't know the Media Lab, it's a place on campus that's kind of a think tank. And so they develop everything from new cars and new toys to synthetic neurobiology to biomechatronics and even food. So when I approached this in my work, I started with this picture, which I think follows up great on the last presentation. If I said to you food crisis, it's likely that every one of you in this room would have a different thing in your mind. You might be thinking not enough food, you might be thinking too much food, agricultural runoff creating algal blooms, not enough water, food insecurity, GMO is saving the world, GMO is the blight of the world, farmers' land taken away from them, that land was taken from a rainforest, attenuation of nutrition, urbanization, it goes on, and I think the current message of food crisis is incredibly disempowering. Because by the time you hear all of that stuff, you're like, oh man, someone should fix this big problem. So the derivative as it goes to the UAE, in my opinion, so the UAE imports 85% of its own food, probably not a huge shock to those that live here, at the cost of 15% GDP, which is quite significant. So you can imagine the cost of imports are rising because of climate change, food supply chains are getting more insecure, so this could be a scary thing. But it could also be the biggest opportunity of this generation to take back part of that 85% and to take back part of that 15% GDP. So these are my what ifs for my work that I'm trying to make happen. What if there was climate democracy? And what I mean is this map is the map of the most beneficial climates in the world for agriculture in green, the least in red. Climates are changing and moving, and Californian farmers are now Mexican farmers. China is the largest landholder in Brazil, and a lot of the food from the UAE is coming in from Africa. So we are currently slave to climate. Could we start producing beneficial climates anywhere? The next question, super serious. If you've ever seen this part of Willy Wonka, they just zapped a candy bar. They turned that candy bar into data. It flows through the air and it goes to the other side and becomes a candy bar again. The world today is described more by data than ever before. When you have Pokemon Go becoming a billion-dollar company in a week with more users than Twitter and Tinder combined from a silly game that you flick on your phone, you need to know that we can create enough data about things that now maybe this is possible with food. We ship data, not food. The last one, I started this work post-Fukushima. I went to Japan. I landed that day and the headline read, Japanese agriculture has no youth, no money, no land, and no future. It isn't only in Japan. In the United States, 2% of us are farmers. The average age is 58. As you keep going, 80% of the African young population doesn't want to be farmers. They've left, they're going into the cities, they're looking for new opportunities. In India, more farmer suicides in the last 3 years than the previous 10. People are leaving farming in droves all around the world. So who are that next generation? And we'll talk about that. So I look at movements that I've seen in my life and been adjacent to or a part of. So coder movement, access to hardware, Linux, HTML, the building of the internet. Maker movement, we're kind of maybe towards the tail end of. Network movement, and then the last one, food movement. In the last 2 years, 6 out of the 30 labs of the Media Lab are doing biology. This is a phenomenon that has never been the case since the inception of the lab in the 80s. So we are starting to use digital tools with a new fluency towards biology that's exactly like that 60s, 70s era of computing. So this is part of my work. One is called production platforms. You've probably seen things like this before. This is one of the first labs I built, and we can talk about the technology. This was 5 or 6 years ago. But I think the most important thing was that once a month we had a harvest. And right in the middle of the Media Lab, bright white roots, deep green colors. Like, is this a new grocery store? Is this a new school cafeteria experience? Those are big questions, but I know for one thing, this is the first time anyone in the Media Lab ever ripped the roots off of anything. We get our salad in bags. This growing is not a part of our life. So this moment inspired roboticists, algorithms experts, data scientists, mechanical, electrical engineers to get involved. So my next lab is on the facade of the Media Lab. And if you know about the genome or genetics, what we're talking about is the phenome or the phenomena that surrounds genetics. In here we design climates. Now if that sounds funny, think about if you planted a seed and the same seed around the world. You might end up saying, man, that tomato in Tuscany on the south slope in the summertime with the sheep next door, that's the best tomato. It's really the environment or the phenomena that surrounds it that causes an expression of genetics. So inside of this lab, we've been designing climate to produce flavor. You can imagine that climate recipe as that blue line. So it's trying to follow 1982 Napa. We're going to produce the 100-point Cabernet. All of those zigzaggy lines are all the sensors that we're following to try to conform to that climate. We correlate those recipes to each plant. So in this, each plant has an ID. All the plants next to it are kind of arranged as friends. And what we've essentially created is the Facebook of plants. Each user unique, each user's needs unique, starting to see about combinatory effects between plants that no one's ever known before. This is the lab a few months ago. We've been growing all kinds of things. A lot of people like to talk about aeroponics. Aeroponics was invented in the 80s for a Mir space station. It's a method of reducing water consumption. It's just another kind of irrigation. So inside of that box, there's no soil, there's no standing water, only mist. And that mist will grow things 3 to 5 times as fast. We've also been growing heirloom, ancient, and rare genetics. These tomatoes came from a rare seed bank. So when you think about the tomatoes you get to eat, there are about 5 cultivars of tomatoes that you get to put in your mouth. And they were never picked for flavor. They were never picked for anything other than supply chain ability to withstand supply chain. So these tomatoes hadn't been grown in 150 years. They're supposedly the best sauce tomatoes in the world. Of course, we don't know how to cook, so we're not sure of that. We're also growing cotton. One of my sponsors is the world's largest cotton manufacturer. The water table in India is dropping feet per year. The cotton quality and consistency is threatened globally. So the question is, can you have cotton growing in a factory right next to your ginning, spinning, milling, product making out the other side? For the first time in history, agriculture being 365 days consistent would fundamentally change the economics. We knew these machines were going to be expensive and we needed to curate a community. So we created what we call the personal food computer. Think of this like the first 3D printers or the first people that worked on computers in their garages during that kind of homebrew computer club days. These are weird. They aren't meant to feed people. They're meant to create knowledge, and they're meant to create curiosity. We drop these food computers off in classrooms. First, the student sees the digital climate, sees the sensors, the actuators, loads a recipe that some other student anywhere in the world has grown with before. When they load that recipe, the climate begins. They plant the plant, but they get curious. They say, well, why does a plant need CO2? Maybe it doesn't need CO2. Crank down the CO2, plant dies. Kid learns a lesson about climate science. At the end of it, they harvest, physically and digitally. And when they harvest, they get a derivative recipe. They've now added to the commons of knowledge about what happens to this crop under different climates. They download the data, they do Google Science Fair or whatever else they do with the data, but importantly, it's captured. We've had students do climate studies. So on the left side of this 6 bank, you're seeing a climate that was 50 years old. They used Farmer's Almanac data from 50 years ago to reanimate a climate of the past. They then used data gathered now from GIS and other sources to animate the climate of the present. Then the students predicted the climate of the future based on some of the predictions we heard today. It's a lot more interesting for a young person when you say climate change and they look up and they don't see anything, to when they have climates at their disposal to design in their classrooms to understand the effects of what's going to happen. We released the second version of the personal food computer at the White House a few weeks ago. I'm proud to announce on this stage that right now we're deploying them with the World Food Program and the UN in Amman, in a Syrian refugee camp, to start innovation around growing food there this week. So everything's moving fast. This is one of my new labs that I just built at MIT. We are putting an investment into this space. We're scaling up our work into shipping containers and beyond. So if you want to be involved in that, let me know. The second part of the work, so that was all hardware. Now it's all data. So I told you about the phenome. And that's an incredibly complex idea because think of all of the variables. You know, the genome, that's kid stuff. We at least can figure that out because it's easier. But if you're trying to figure out the combinatory effects of 60 variables on an organism, you're going to need some massive computing power. So inside of all the food computers, we collect a lot of the standard data you would expect. Things like temperature and light and humidity and so on. But we also collect mineral data. So this is using a spectrophotometer. So when people say, but it's the terroir. It's the terroir that makes it taste good. Terroir means minerals and carbon and water and oxygen and bacteria and microbes. It's not magic. And so in here, we look through all of those minerals that are being applied to the soil and what their effects are. We also take the root zone and culture it. So we just stick a swab in there, put it on a petri dish, and then we sequence it. And we say, what was alive at that root zone? So when people talk about microbiome right now, what you're seeing is the microbiome of a plant. In the bottom set of the petri dishes is the roots. In the top is the leaves. The leaves are sterile. The roots are full of a vibrant ecosystem of microbes and bacteria that today are not even fully understood. So we're collecting all of this data in concert. The last one, when the plant is finished, we do analytical chemistry. We want to know what's in it. When people say it's good, why is it good? What is flavor? How do you quantify it? In this, we use gas chromatography and mass spec to get down to the compound level. So if we want to know what good is, now we can link that to what bacteria's made it good. We use computer vision because it's non-invasive and it's cheap. We would love to replace all of the sensors that we use, and someday we will with new advances in computer vision. We tie all of that together. So 3.5 million data points per plant, per grow, fed into a recipe that goes into a robot. So this robot plans, acts, creates climates, learns, and then does it again, over and over. We take all of that data forward to do machine learning. So what you're looking at here is Bayesian optimization and Gauss's processing. What that means is, see these little slices? Each slice represents a two-dimensional graph. So you can test two variables. But when you stack them against each other, you can test a combination of variables and create a heat map. So when you're looking at the little red dots, this is telling us that out of, 3 times 2, so 6, plus another axis, that amount of combinations is giving us a hot spot in some place that we didn't know before. So it's fundamentally new knowledge only possible through massive data sets, which we're just beginning to build, and new tools that everybody's working on, AI and machine learning. These things, of course, exist in the world. Probably Japan's the world leader with something around the neighborhood of I think last I heard 800 hectares of what they call plant factories. So this plant factory grows 1 million heads of lettuce a week, or so I'm told. And you can see it comes out branded Toshiba. And people still eat it. In Japan, the condition is genuine fear of food. We've been fed things before that killed our children. We've been fed things before that had arsenic and lead and possibly radiation. We want clean food. So this is why you're going to see this fetch a 3 times premium in the market. Of course, it doesn't just end at lettuce. So this is a project that grows something very special. Looks kind of the same, looks like things you've seen before. But this is actually growing Ebola vaccine. So this is tobacco plants in a very specific climate, stressed in a very specific way to produce a resistant protein. They harvest that protein off of the plants, they manufacture it into vaccines. This is one of the reasons we got ahead of Ebola. This is a project with Department of Defense and Texas A&M. So everything from pharmaceutical natural derivative, cosmetic, nutraceutical, all the way down to lettuce and herbs. But then reality hits us in the face. So first one is the first vertical farm in the world on Vancouver that went bankrupt in 2013. The next one is farmed here, went bankrupt 3 weeks ago. This is, millions and millions of dollars of investment. And I think this points to the stage and current technology development that we're in. It's early. It's like cars before Ford, when cars were super weird and went too fast or too slow, were all designed by one company. They weren't integrated like cars became later. If you were designing the wheel, you were also designing the motor and the seats and the body. Well, you probably aren't good at all of those things. This is where we are right now. A lot of proprietary intellectual property being sold, the very high questions of what the value of that property is, and so I'm taking a cue from the market in my work. As I span the big tech leaders, one of which we'll talk today, you see Elon Musk, and he open sources the patents of Tesla. Why? Why would Elon give away the thing that he spent a ton of money developing to the general public? Makes no sense. He's a crazy person. He's not crazy. He needs more charging stations. And if he needs more charging stations, he can't also build those. He needs smart roads that work with smart cars. He's not going to be able to build those. So he needs people to understand what he's doing so that they can supply infrastructure to work with him. Apple, the most proprietary company of all time, going open source with their app developer language. Facebook, the biggest asset they have right now, their AI, called TorchNet. TorchNet, TensorFlow, going open source. Human Genome Project, one of the most influential science projects of this generation, was open source because it had to be. It has to hit the network, you have to test the knowledge, and you need a community of participators with you along for a journey of changing the world. And that's what we need to do in food. So all of the work from our lab is open source. Hardware, software, and data, we share it out, and we look and see what happens. And these crazy people around the world have downloaded our videos for the small food computer because it's reasonable to build yourself, and have started building it all over the world. We then started a forum because they needed to get together and talk to each other. So we started a little Reddit-style forum. Please, if you're interested in this and you feel like maybe you want to contribute but you don't know how or where, there's a whole bunch of you in our forum that are asking each other questions. So please log in, become a farmer, and contribute whatever it is you have. This has spurred a kind of maker movement of food. So this is a thing we did with National Geographic where we collected students from all over the United States. They built their own personal food computers in 2 days. They took them home to their schools, and they started homebrew food computer clubs. Exactly the same thing that was going on when you saw these guys like Gates playing around in their garages. And of course, the network is really important. So working with projects like Museum of Future, Auto Farm, I hope you guys go check it out. But the question is, how can our tech, your tech, all of the different people working on this somehow benefit from the network? So that's what we've built now. This is the first time I've really started to talk about what we've been planning. So we have the research. And if you look into our work, you'll find that last month, Secretary Kerry, former Secretary Kerry, announced a partnership between us and Vietnam. With Cantao University, we've expanded with partnerships in Chiba University in Japan. We're talking about Museum of the Future now here. So that's on research. And then you need something to protect the commons. So we've created a nonprofit because you don't ever want that data to be sold. You don't ever want the hardware to be sold, and you don't ever want the software to be sold. If HTML and Linux were proprietary, the internet would have never existed. So we've created a fully nonprofit device for putting all of that in. And now it's spurred this commercialization layer. So with some of our partners like Food and Future that's here and going to talk, with other spinoffs that have come out of my group, they're now taking open source tech, raising VC funds, which everybody wants to put in, to change the world of food. So this is exciting and new. Our work has now expanded to 20 countries in 6 continents without a whole lot of major funding. This is just people that were excited, that were interested, that downloaded our code, that built our funny looking little machines, and started putting data up about what they were doing. This is the world today, a complex system. We've got any country with a color is food insecure. That's 80%. Of the world is food insecure. Any country that's both red and then purple is a country that is providing food for another country. So most of them are food insecure and providing food to other countries. Then you've got the complex distribution lines on top of it. Planes, trains, and automobiles, our inheritance from the Industrial Revolution. This is what we're dealing with today. A very big, very global farm that was very good for the call in the 70s. Which was more cheap food. Now we're asking for better, more sustainable, more nutritious food. And this is the future. We will start bringing online digital farms that are sending climate files to other farms to animate Mexico in Abu Dhabi, or to animate Burgundy in India. It's already started to happen. I invite all of you to participate in whatever way you want, supporting the education, building the machines, creating commercial ventures off of open systems. The future of food is not about everybody camping off, which is what's happening now. No, GMO is bad. No, it's good. No, organic is good. No, it's bad. It's not about that. It's about networking the next 1 billion farmers with common and open tools to simply ask the question, what if? Thank you.